The thallium halides include monohalides, where thallium has oxidation state +1, trihalides where thallium generally has oxidation state +3 and some intermediate halides with mixed +1 and +3 oxidation states. These materials find use in specialized optical settings, such as focusing elements in research spectrophotometers. Compared to the more common zinc selenide-based optics, materials such as thallium bromoiodide enable transmission at longer wavelengths. In the infrared, this allows for measurements as low as 350 cm-128 micrometers, whereas zinc selenide is opaque by 21.5 micrometers and zinc selenide optics are generally only usable to 650 cm-115 micrometers. Monohalides. The monohalides all contain thallium with oxidation state +1. Parallels can be drawn between the thallium I halides and their corresponding silver salts, for example thallium I chloride and bromide are light-sensitive and thallium I fluoride is more soluble in water than the chloride and bromide. Thallium I fluoride TLF is a white crystalline solid, with a MP of 322 degrees Celsius. It is readily soluble in water unlike the other Tl(I) halides. The normal room temperature form has a similar structure to alpha PbO, which has a distorted rock salt structure with essentially 5-coordinate thallium. The sixth fluoride ion is at 370 pm. At 62 degrees Celsius it transforms to a tetragonal structure. This structure is unchanged up to pressure of 40 gigapascals. The room temperature structure has been explained in terms of interaction between TL6s and the F2p states producing strongly antibonding TLF states. The structure distorts to minimize these unfavorable covalent interactions. Thallium I chloride TLCl is a light-sensitive white crystalline solid, MP 430 degrees Celsius. The crystal structure is the same as cesium chloride. Thallium I bromide TLBr is a light-sensitive pale yellow crystalline solid, MP 460 degrees Celsius. The crystal structure is the same as cesium chloride. Thallium I iodide. At room temperature TLI is a yellow crystalline solid, MP 442 degrees Celsius. The crystal structure is a distorted rock salt structure known as the beta-TLI structure. At higher temperatures the color changes to red with a structure the same as cesium chloride. Thallium I mixed halides. Thallium bromoiodide and thallium bromochloride are mixed salts of thallium I that are used in spectroscopy as an optical material for transmission, refraction and focusing of infrared radiation. The materials were first grown by R. Koops in the laboratory of Oleksandr Smykula at the Carl Zeiss Optical Works, Jena in 1941. The red bromoiodide was coded KRS5 and the colorless bromochloride, KRS6, and this is how they are commonly known. The KRS prefix is an abbreviation of Kristal aus dem Schmelzfluss, crystals from the melt. The compositions of KRS5 and KRS6 approximate to TLBr 0.4 I 0.6 and TLBr 0.3 Cl 0.7. KRS5 is the most commonly used. Its properties of being relatively insoluble in water and non-hygroscopic make it an alternative to KBr, CSI and silver 1 chloride. Trihalides. The thallium trihalides are less stable than their corresponding aluminium, gallium and indium counterparts and chemically quite distinct. The triiodide does not contain thallium with oxidation state +3 but is a thallium I compound and contains the linear triiodide I3- ion. Thallium 3 fluoride TLF3 is a white crystalline solid, MP 550 degrees Celsius. The crystal structure is the same as YF3 and beta-bismuth 3 fluoride. In this the thallium atom is 9-coordinate, tricapped trigonal prismatic. It can be synthesized by fluoridation of the oxide, Tl2O3, with F2, bromine trifluoride or SF4 at 300 degrees Celsius. Thallium 3 chloride TLCl3 has a distorted Cr chloride structure like aluminium chloride and InCl3. Solid TlCl3 is unstable and disproportionates at 40 degrees Celsius, losing chlorine to give TlCl. It can be prepared in CH3CN by treating a solution of TlCl with Cl2 gas, thallium-3 bromide. This unstable compound disproportionates at less than 40 degrees Celsius to TlBr2. It can be prepared in CH3CN by treating a solution of TlBr with bridge 2 gas. In water, the tetrahydrate complex can be prepared by adding bromine to a stirred suspension of TlBr, thallium I triiodide. TLI3 is a black crystalline solid prepared from TLI and I2 in aqueous high. It does not contain thallium-3, but has the same structure as cesium iodide containing the linear I3- ion. Mixed valence halides. As a group, these are not well characterized. They contain both Tl and Tl3, where the thallium-3 atom is present as complex anions, e.g. TlCl4-, TlCl2. This is formulated as Tolidlycol-4, Tl2Cl3. This yellow compound is formulated Tli3 TliiICl6, Tl2 bridge 3. This compound is similar to Tl2Cl3 and is formulated Tli3 TliiIBr6 TlBr2. This pale brown solid is formulated Lit 4 teraliters 3I4. This compound has been reported as an intermediate in the synthesis of TLI3 from TLI and I2. The structure is not known. Halide complexes. Thallium I complexes. Thallium I conform complexes of the type TLX3 2- and TLX4 3-, both in solution and when thallium I halides are incorporated into alkali metal halides. These doped alkali metal halides have new absorption and emission N bands and are used as phosphors in scintillation radiation detectors. Thallium-3 fluoride complexes. The salts NaTlF4 and Na3TlF6 do not contain discrete tetrahedral and octahedral anions. The structure of NaTlF4 is the same as fluorite, calcium fluoride, with Ni and TlIII atoms occupying the 8-coordinate Ke sites. Na3TlF6 has the same structure as cryolite, Na3 aluminium fluoride. In this, the thallium atoms are octahedrally coordinated. Both compounds are usually considered to be mixed salts of Na+ and Tl3+, thallium-3 chloride complexes. Salts of tetrahedral TlCl4- and octahedral TlCl63- are known with various cations. Salts containing TlCl52- with a square pyramidal structure are known. Some salts that nominally contain TlCl52- actually contain the dimeric anion Tl2Cl104-, long-chain anions where TlIII is 6-coordinate and the octahedral units are linked by bridging chlorine atoms, or mixed salts of TlIIICl4 and TlIIICl6. The ion Tl2Cl93- where thallium atoms are octahedrally coordinated with 3 bridging chlorine atoms has been identified in the cesium salt, Cs 3 teraliters 2Cl9, thallium-3 bromide complexes. Salts of TlIIIBr4- and TlIIIBr63- are known with various cations. The TlBr52- anion has been characterized in a number of salts and is trigonal bipyramidal. Some other salts that nominally contain TlBr52- are mixed salts containing TlBr4- and bridge-, thallium-3 iodide complexes. Salts of Tli4- are known. The TlIII anion is stable even though the triiodide is a thallium I compound. General references. Greenwood, Norman N., Earnshaw, Alan 1997. Chemistry of the Elements, 2nd ed. Butterworth Heinemann, ISBN 0-08-037941-9. Cotton, F. Albert, Wilkinson, Jeffrey, Murillo, Carlos A., Bachmann, Manfred 1999, Advanced Inorganic Chemistry, 6th ed. New York, Wiley Interscience, ISBN 0-471-19957-5. Footnotes